The limits of discovery in the planetary bodies, and in this one especially, thus seem to be immutably fixed, and no expectation was elevated for a period of several years. But about 3 years ago, in the course of a conversational discussion with Sir David Brewster upon the merits of some ingenious suggestions by the latter, in his article on optics in the Edinburgh Encyclopedia, page 644, for improvements in the Newtonian reflectors, Sir John Herschel adverted to the convenient simplicity of the old astronomical telescopes that were without tubes, and the object glass of which, placed upon a high pole, threw its focal image to a distance of 150 and even 200 feet. Dr. Brewster readily admitted that a tube was not necessary, provided the focal image were conveyed into a dark apartment and there properly received by reflectors. Sir John then said that if his father's great telescope, the tube alone of which, though formed of the lightest suitable materials, weighed 3,000 pounds, possessed an easy and steady mobility with its heavy observatory attached. An observatory movable without the encumbrance of such a tube was obviously practical. This also was admitted, and the conversation became directed to that all-invincible enemy. The paucity of light in powerful magnifiers. After a few moments silent, though, Sir John diffidently inquired whether it would not be possible to effect a transfusion of artificial light through the focal object of vision. Sir David, somewhat startled at the originality of the idea, paused a while and then hesitatingly referred to the refrangibility of rays and the angle of incidence. Sir John, grown more confident, adduced the example of the Newtonian reflector, in which the refrangibility was corrected by the second speculum, and the angle of incidence restored by the third. And continued he, why cannot the illuminated microscope, say the hydro-oxygen, be applied to render distinct, and if necessary, even to magnify the focal object? Sir David sprung from his chair in an ecstasy of conviction, and leaping halfway to the ceiling, exclaimed, "Thou art the man!" Each philosopher anticipated the other in presenting the prompt illustration that if the rays of the hydro-oxygen microscope passed through a drop of water containing the larvae of a gnat and other objects invisible to the naked eye, rendered them not only keenly but firmly magnified in dimensions of many feet, so could the same artificial light pass through the faintest focal object of a telescope, both distinctly, to coin a new word for an extraordinary occasion, and magnify its feeblest component members. The only apparent desideratum was a recipient for the focal image which should transfer it, without refranging it, to the surface on which it was to be viewed under the revivifying light of the microscopic reflectors. In the various experiments made during the few following weeks, the cooperative philosophers decided that a medium of the purest plate glass, which it is said they obtained by consent, be it observed from the shop window of Mons Desanges, the jeweler to his ex-majesty Charles X, in High Street, was the most eligible they could discover. It answered perfectly with a telescope which magnified 100 times and a microscope of about thrice that power. Sir John Herschel then conceived the stupendous fabric of his present telescope. The power of his father's instrument would still leave him distant from his favorite planet nearly 40 miles, and he resolved to attempt a greater magnifier. Money, the wings of science as the sinews of war, seemed the only requisite, and even the acquisition of this, which is often more difficult than the task of Sisyphus, he determined to achieve. Fully sanctioned by the high optical authority of Sir David Brewster, he laid his plan before the Royal Society, and particularly directed to it the attention of His Royal Highness the Duke of Sussex, the ever-munificent patron of science and the arts. It was immediately and enthusiastically approved by the committee chosen to investigate it, and the chairman, who was the royal president, subscribed his name for a contribution of £10,000, with the promise that he would zealously submit the proposed instrument as a fit object for the patronage of the privy purse. He did so without delay, and His Majesty, on being informed that the estimated expense was £70,000, naively inquired if the costly instrument would conduce to any improvement in navigation. On being informed that it undoubtedly would, the sailor king promised a carte blanche for the amount which might be required. Sir John Herschel had submitted his plans and calculations in adaptation to an object glass of 24 feet in diameter, just 6 times the size of his venerable father's. For casting this ponderous mass, he selected the large glass house of Messrs. Hartley and Grant, the brother of our invaluable friend Dr. Grant, at Dumbarton. The material chosen was an amalgamation of 2 parts of the best crown with one of flint glass, the use of which in separate lenses constituted the great achromatic discovery of Dollond. It had been found, however, by accurate experiments that the amalgam would as completely triumph over every impediment, both from refrangibility and discoloration, as these separate lenses. 5 furnaces of the metal carefully collected from productions of the manufactory in both the kinds of glass and known to be respectively of nearly perfect homogeneous quality were united by one grand conductor to the mold, and on the 3rd of January 1833 the first cast was effected. After cooling 8 days, the mold was opened, and the glass found to be greatly flawed within 18 inches of the center. Notwithstanding the failure, a new glass was more carefully cast on the 27th of the same month, which, on being opened during the first week of February, was found to be immaculately perfect, with the exception of 2 slight flaws, so near the line of its circumference that they would be covered by the copper ring in which it was designed to be enclosed. The weight of this prodigious lens was 14,826 pounds, or nearly 7 tons after being polished, and its estimated magnifying power 42,000 times. It was therefore presumed to be capable of representing objects in our lunar satellite of little more than 18 inches in diameter, provided its focal image of them could be rendered distinct by the transfusion of artificial light. It was not, however, upon the mere illuminating power of the hydro-oxygen microscope, as applied to the focal pictures of this lens, that the younger Herschel depended for the realization of his ambitious theories and hopes. He calculated largely upon the almost illimitable applicability of this instrument as a second magnifier, which would supersede the use and infinitely transcend the power of the highest magnifiers in reflecting telescopes. So sanguinely, indeed, did he calculate upon the advantages of this splendid alliance that he expressed confidence in his ultimate ability to study even the entomology of the moon, in case she contained insects upon her surface. Having witnessed the completion of this great lens and its safe transportation to the metropolis, his next care was the construction of a suitable microscope and of the mechanical framework for the horizontal and vertical action of the whole. His plans in every branch of his undertaking, having been intensely studied even to their minutest details, were easily and rapidly executed. He awaited only the appointed period of which he was to convey his magnificent apparatus to its destination. A correspondence had for some time passed between the boards of England, France, and Austria with a view to improvements in the tables of longitude in the southern hemisphere, which were found to be much less accurate than those of the northern. The high opinion entertained by the British Board of Longitude of the principles of the new telescope and of the profound skill of its inventor determined the government to solicit his services in observing the transit of Mercury over the sun's disk, which will take place on the 7th of November in the present year, and which, as it will occur at 7 hours 47 minutes 55 seconds night conjunction meantime, and at 8 hours 12 minutes 22 seconds middle true time, will be invisible to nearly all the northern hemisphere. The place at which the transits of Mercury and of Venus have generally been observed by the astronomers of Europe when occurring under these circumstances is the Cape of Good Hope, and no transit of Venus having occurred since the year 1769, and none being to occur before 1874, the accurate observation of the transits of Mercury, which occur more frequently, has been found of great importance both to astronomy and navigation. To the latter useful art, indeed, the transits of Mercury are nearly as important as those of Venus. For although those of the latter planet have the peculiar advantage of determining exactly the great solar parallax, and thence the distances of all the planets from the Sun, yet the transits of Mercury, by exactly determining the place of its own node, independently of the parallax of the great orb, determine the parallax of the Earth and Moon, and are therefore especially valuable in lunar observations of longitude. The Cape of Good Hope has been found preferable in these observations to any other station in the hemisphere. The expedition which went to Peru about the middle of the last century to ascertain, in conjunction with another in Lapland, the true figure of the Earth, found the attraction of the mountainous regions so strong as to cause the plumb line of one of their instruments to deflect 7 or 8 seconds from the true perpendicular, whilst the elevated plains of the Cape unite all the advantages of a lucid atmosphere with entire freedom from mountainous obstruction. Sir John Herschel therefore not only accepted the appointment with high satisfaction, but requested that it might commence at least a year before the period of the transit, to afford him time to bring his ponderous and complicated machinery into perfect adjustment, and to extend his knowledge of the southern constellations. His wish was immediately assented to, and his arrangements being completed, he sailed from London on the 4th of September, 1834, in company with Dr. Andrew Grant, Lieutenant Drummond of the Royal Engineers, FRAS, and a large party of the best English mechanics. They arrived after an expeditious and agreeable passage, and immediately proceeded to transport the lens and the frame of the large observatory to its destined site, which was a piece of tableland of great extent and elevation, about 35 miles to the northeast of Cape Town, and which is said to be the very spot on which De la Caille, in 1750, constructed his invaluable solar tables, when he measured a degree of the meridian and made a great advance to exactitude in computing the solar parallax from that of Mars and the Moon. Sir John accomplished the ascent to the plains by means of 2 relief teams of oxen of 18 each in about 4 days, and aided by several companies of Dutch boors, proceeded at once to the erection of his gigantic fabric. The ground plan of the structure is in some respects similar to that of the Herschel telescope in England, except that instead of circular foundations of brickwork, it consists of parallel circles of railroad iron upon wooden framework so constructed that the turnouts, or rather turn-ins, from the largest circle will conduct the observatory, which moves upon them, to the innermost circle, which is the basis of the lens works, and to each of the circles that intervene. The diameter of the smallest circle is 28 feet. That of the largest our correspondent has singularly forgotten to state, though it may be in some measure computed from the angle of incidence projected by the lens and the space occupied by the observatory. The latter is a wooden building 50 feet square and as many high, with a flat roof and gutters of thin copper. Through the side proximate to the lens is an aperture 4 feet in diameter to receive its rays, and through the roof another for the same purpose in meridional observations. The lens, which is enclosed in a frame of wood and braced to its corners by bars of copper, is suspended upon an axis between 2 pillars which are nearly as high as those which supported the celebrated quadrant of Ulugh Beg, being 150 feet. These are united at the top and bottom by cross pieces and strengthened by a number of diagonal braces. Between them is a double capstan for hoisting the lens from its horizontal line with the observatory to the height required by its focal distance, when turned to the meridian, and for elevating it to any intermediate degree of altitude that may be needed. The last operation is beautifully regulated by an immense double sextant, which is connected and moves with the axis of the lens, and is regularly divided into degrees, minutes, and seconds, and the horizontal circles of the observatory being also divided into 360 degrees and minutely subdivided, the whole instrument has the powers and regularity of the most improved theodolite. Having no tube, is connected with the observatory by two horizontal levers, which pass underneath the floor of that building from the circular basis of the pillars, thus keeping the lens always square with the observatory and securing to both a uniform and simple movement. By means of these levers, too, a rack and windlass, the observatory is brought to any degree of approximation to the pillars that the altitude of an observation may require. And although when at its nearest station it cannot command an observation with the great lens within about 15 degrees of the meridian, is supplied with an excellent telescope of vast power, constructed by the elder Herschel, by which every high degree can be surveyed. The field of view, therefore, whether exhibited on the floor or on the wall of the apartment, has a diameter of nearly 50 feet, and being circular, is therefore an area of nearly 1875 feet. The place of all the horizontal movements have been accurately leveled by Lieutenant Drummond with the improved level of his invention, which bears his name, and the wheels both of the observatory and of the lens works being facilitated by friction rollers in patent axle boxes filled with oil and strength of one man applied to the extremity of the levers, is sufficient to propel the whole structure upon either of the railroad circles, and that of two men applied to the windlass is fully adequate to bring the observatory to the basis of the pillars. Both of these movements, however, are now effected by a locomotive apparatus commanded within the apartment by a single person, and showing by means of an ingenious index every inch of progression or retrogression. We have not thus particularly described the telescope of the younger Herschel because we consider it the most magnificent specimen of philosophical mechanism of the present or any previous age, but because we deem an explicit description of its principles and powers an almost indispensable introduction to a statement of the sublime expansion of human knowledge which it has achieved. It was not fully completed until the latter part of December, when the series of large reflectors for the microscope arrived from England, and it was brought into operation during the first week of the ensuing month and year. But the secrecy which had been maintained with regard to its novelty, its manufacture, and its destination was not less rigidly preserved for several months respecting the grandeur of its success. Whether the British government were skeptical concerning the promised splendor of its discoveries, or wished them to be scrupulously veiled until they had accumulated a full-orbed glory for the nation and reign in which they originated, is a question which we can only conjecturally solve. But certain it is that the astronomer's royal patrons enjoined a Masonic taciturnity upon him and his friends until he should have officially communicated the results of his great experiment. Accordingly, the world heard nothing of him or his expedition until it was announced a few months since in the scientific journals of Germany that Sir John Herschel at the Cape of Good Hope had written to the Astronomer Royal of Vienna to inform him that the portentous comet predicted for the year 1835, which was to approach so near this trembling globe that we might hear the roaring of its fires, had turned upon another scent, and would not even shake a hair of its tail upon our hunting grounds. At a loss to conceive by what extra authority he had made so bold a declaration, the men of science in Europe were not acquainted with his secret regarded his postponement, as his discovery was termed, with incredulous contumely, and continued to terrorize upon the strength of former predictions. New lunar discoveries. Until the 10th of January, the observations were chiefly directed to the stars and the southern signs, in which, without the aid of the hydro-oxygen reflectors, a countless number of new stars and nebulae were discovered, but we shall defer a correspondence account of these to future pages, for the purpose of no longer withholding from our readers the more generally and highly interesting discoveries which were made in the lunar world. And for this purpose, too, we shall defer Dr. Grant's elaborate mathematical details of the corrections which Sir John Herschel has made in the best tables of the moon's tropical, sidereal, and synodic revolutions, and of those phenomena of syzygies on which a great part of the established lunar theory depends. It was about 9:30 on the night of the 10th, the moon having then advanced within 4 days of her mean libration, that the astronomer adjusted his instruments for the introspection of her eastern limb. The whole immense power of his telescope was applied, and to its focal image about 1/2 of the power of his microscope. On removing the screen of the latter, the field of view was covered throughout its entire area with a beautifully distinct and even vivid representation of basaltic rock. Its color was a greenish brown, and the width of the columns, as defined by their interstices on the canvas, was invariably 28 inches. No fracture whatever appeared in the mass first presented, but in a few seconds a shelving pile appeared of 5 or 6 columns width, which showed their figure to be hexagonal and their articulations similar to those of the basaltic formation at Staffa. This precipitous shelf was profusely covered with a dark red flower, precisely similar, says Dr. Grant, to the Papaver reyes, or rose poppy, of our sublunary cornfields, and this was the first organic production of nature in a foreign world ever revealed to the eyes of men. The rapidity of the moon's ascension, or rather of the Earth's diurnal rotation, being nearly equal to 500 yards in a second, would have effectually prevented the inspection or even the discovery of objects so minute as these, but for the admirable mechanism which constantly regulates under the guidance of the sextant the required altitude of the lens. But its operation was found to be so consummately perfect that the observers could detain the object upon the field of view for any period they might desire. The specimen of lunar vegetation, however, which they had already seen, had decided a question of too exciting an interest to induce them to retard its exit. It had demonstrated that the moon has an atmosphere constituted similarly to our own, and capable of sustaining organized and therefore most probably animal life. The basaltic rocks continued to pass over the inclined canvas plane through 3 successive diameters when a verdant declivity of great beauty appeared, which occupied 2 more. This was preceded by another mass of nearly the former height, at the base of which they were at length delighted to perceive that novelty, a lunar forest. The trees, say Dr. Grant, for a period of 10 minutes, were of one unvaried kind, and unlike any I have seen, except the largest kind of yews in the English churchyards, which they in some respects resemble. These were followed by a level green plain, which, as measured by the painted circle on our canvas of 49 feet, must have been more than half a mile in breadth, and then appeared as fine a forest of firs, unequivocal firs, as I have ever seen cherished in the bosom of my native mountains. Wearied with the long continuance of these, we greatly reduced the magnifying power of the microscope without eclipsing either of the reflectors, and immediately perceived that we had been insensibly descending, as it were, a mountainous district of a highly diversified and romantic character, and that we were on the verge of a lake or inland sea, but of what relative locality or extent we were yet too greatly magnified to determine. On introducing the feeblest achromatic lens we possessed, we found that the water, whose boundary we had just discovered, answered in general outline to the mare nubium of Ricoli, by which we detected that instead of commencing, as we suppose, on the eastern longitude of the planet, some delay in the elevation of the great lens had thrown us nearly upon the axis of her equator. However, as she was a free country, and we not as yet attached to any particular province, and moreover, since we could at any moment occupy our intended position, we again slid in our magic lenses to survey the shores of the mare nubium. Why Ricole so termed it, unless in ridicule of Clemedes, I know not, for fair shores never angels coasted on a tour of pleasure. a beach of brilliant white sand, girt with wild castellated rocks, apparently of green marble, varied at chasms occurring every 200 or 300 feet, with grotesque blocks of chalk or gypsum, and feathered and festooned at the summit with the clustering foliage of unknown trees, moved along the bright wall of our apartment until we were speechless with admiration. The water, wherever we obtained a view of it, was nearly as blue as that of the deep ocean, and broke in large white billows upon the strand. The action of very high tides was quite manifest upon the face of the cliffs. For more than 100 miles, yet diversified as the scenery was during this and a much greater distance, we perceived no trace of animal existence, notwithstanding we could command at will a perspective or a foreground view of the whole. Mr. Holmes, indeed, pronounced some white objects of a circular form, which we saw at some distance in the interior of a cavern, to be bona fide specimens of a large cornu amanus. But to me they appeared merely large pebbles, which had been chafed and rolled there by the tides. Our chase of animal life was not yet to be rewarded.